Good afternoon, Algebra 2 students. Today we've got 10.5. It's not really 10.5, just calling it that. We've got 2 additional days of statistics and probability here. So it's kind of just some mix match of different stats and probability stuff going on. So I'm just going to be flying through a good handful of examples here. Your homework's got a number of different problems on it. So to start with, we're just talking about outliers. So this is really straightforward. Your data today, for the most part, is laid out from smallest to largest. And all we've got to be doing is just identifying any outliers. And if there's multiple outliers, you would list them all. So as we can see here, all these different numbers of laps that people have completed from the 70s through the 80s, couple in the 90s, and then there's just one at 155. That's your outlier. That's it. That's all the question is asking. If there was a couple of them, like 155 and 160, we'd call both of those our outliers. If we had something down at the other end, like 6, that would be an outlier as well, okay? So your outlier can be in either direction, just one set of data that does not match the rest. If we were taking the average of the age of students in this class, or age of people in this class, my age would be the outlier. I would not be a good representation of the average of all the students, so we'd probably just disregard mine. Okay? Now, when we're looking at, a lot of today is box and whisker plots. When we're looking at these sets of data and trying to figure out the lower quartile, upper quartile, these definitions over on the right side are going to help. So you've got to answer these 5 questions: the minimum value, the lower quartile, the median, which is the middle, the upper quartile, and the maximum. Well, we should be able to figure out 3 of them right away. They're listed in order from least to greatest. It tells you that right away. So the minimum is going to be the smallest value over on the left. That's going to be 5. The maximum is going to be the biggest value over on the right. That's 47. And then the median is whatever is in the middle, okay? Well, there's 13 families, so we're going to find that middle just by kind of walking ourselves in from each side. So if there's 13 values, the 7th value will be the middle. 1, 2, 3, 4, 5, 6 in from the left. You end up with 27. And you can see there's still 6 terms on the right as well. So 27 is right in the middle. That's going to be your median. Remember, if there's two values in the middle, if you have an even number of values, you would take the average of those 2 middle values, right? So if you had something like 1, 6, 8, 10, if you have 4 sets of data, the median would be whatever the middle value of the 2 middle values is, the average of those 2 middle values, which would be 7. So just know that in case you have an even number of data values in any of your examples or your problems. So then we get into these quartile conversations. So the definitions here are what really make a little sense. The lower quartile is the median of the lower half. That word quartile should kind of push you towards the understanding that we're pretty much cutting this into quarters. So once you cut it in half at the median, now we're talking about, okay, what is the median of the lower half? So that would be kind of the lower quarter. So since there's 6 values here, the median would be whatever is the average of the 2 middle terms. Well, they're both 16, so the average of those is 16. So your lower quartile is 16 between those 6 values on the left. And then the upper quartile is the median of the upper half. So now we're talking about these 6 values. Okay, well, your 2 middle values are 32 and 42. You add those together, you get 74. You divide that by 2. Your upper quartile is going to be 37. So it's a little tricky because 37 is not a value that's in the data, but that kind of marks that midway point that splits the upper half into 2 equal portions. Okay, so now you can kind of see we have a lower quarter, a second quarter, the middle term, a third quarter, and a fourth quarter. So we've cut that into quartiles with those terms, those quartile terms, okay? And then the last thing that you're asked to do is find that interquartile range. So what that is, again, there's a definition over here, it's the upper minus the lower. So they're basically just trying to figure out that middle chunk of data from the first quartile to the third quartile, that middle chunk of data, what is the range of that middle chunk? And you're going to see then it's 37 minus 16. Your interquartile range would be 21. Okay? So now we get into the box and whisker plots. And what I've done here is I've put the beginning example, what you're going to see on Alex, and then the final answer on the right. So the following are the distances in miles to the nearest airport for 17 families. Notice that the numbers are ordered from least to greatest. Make a box and whiskers plot. Well, the box and whisker plot is made using these 5 values. Okay? So these 5 values are what you need for a box and whisker plot. Okay, so what you're going to see on Alex is you'll start with what's on the left here. Just a box and whiskers plot that you're going to click and drag all 5 of those points. So you're going to click and drag those points where they need to go. Okay, so this value on the far left is your minimum. So that in this case would be 12. And if you notice, we have 12 on the right hand side. The beginning of the box is your lower quartile. So that lower quartile value is going to be the beginning of the box, and we'll talk about the data here in a second. That middle term, right in the middle, I think you guys could probably guess, that's your median. The right side of the box is your upper quartile, and then that last value is your maximum. And in this case, with this data, we can see that that's at 42. Okay? So if there's 17 families, the 9th term will be the median. So 1, 2, 3, 4, 5, 6, 7, 8. So 22 is right in the middle. Then make sure there's still the same amount of numbers on the right side. 1, 2, 3, 4, 5, 6, 7, 8. So you kind of just count in from the left and the right. You get that middle term of 22. So since it's an odd number, we have an exact middle value. In this case, it's 22. And then the quartiles, remember, are the median of each half. So there's 8 values going on here. So we've got 1, 2, 3, 4, 5, 6, 7, 8 values on the left-hand side. So the 4th and 5th values are in the middle. You would have to find the average of those two. So what's in between 16 and 17? That's going to be 16 and a half. So 16.5 is that lower quartile, and then the upper quartile is going to be the median of the right-hand side. And again, the 4th and 5th values, 33 and 33, since they're both 33, then 33 is your upper quartile value. So then on your homework, you're just clicking and dragging that thing around. Okay? So here we'll make a box and whiskers plot. So again, the max, the min, and the median are all things we can find real quickly. So that minimum is 57. So your whisker here, that's a little off. Your whisker here is going to go all the way down to 57. So that's going to be where your low end point is. Your maximum, the other whisker, is going to be all the way to 93. So we're going to be right about there. So those are where your 2 whiskers are going to end up. Okay? So now the median is going to be the middle. So the median, if there are 16 scores here, we've got 1, 2, 3, 4, 5, 6, 7, 8. And then that value of 80 is your 9th term. So those 2 terms are in the middle. So the median is the average of those 2 terms. Well, what's in the middle of 76 and 80? That's going to be 78. So 78 will be your median. Okay? And then the upper quartile and lower quartile. So you're going to take the median of these values, and that's going to be 70. Whoops. and then the upper quartile is going to be 88. So you can see now when we make that box and whiskers plot, and this is kind of messy, but I'll do my best. Okay, so when you make that box and whiskers plot, it's not always going to be exactly even with how those two boxes look for the quartiles or how those whiskers look. You can tell that the whisker on the right-hand side is quite a bit shorter than the left-hand side. But on Alex, you would start with that box and the whiskers, and you're dragging those points to where they need to be. Okay, so those 5 values that we found in that first example, those are the 5 values that make the box and whisker plot. Okay, so now you're just kind of comparing them. So which city had a noon temperature with a larger interquartile range? So remember the interquartile range, that's what the IQR stands for. Interquartile range is the distance or the difference between the two quartiles. Okay, so it's the third quartile minus the first quartile. So you could end up subtracting those values, or just by looking at this, the third quartile to the first quartile in the top one compared to the third quartile and the first quartile in the second one, which box is bigger? Looks like city A spreads that box out quite a bit further, so that interquartile range is larger in city A, right? Which city had the highest noon temperature? So when they're asking about the highest, they're talking about your maximum. Which city had the highest maximum? Well, we know those two whiskers on the left end is the minimum, the right end is the maximum. Okay, so which one has the highest maximum? That's going to also be city A, because that whisker goes out to the right quite a bit further. Which city had a smaller range of noon temperatures? So when we're just talking about overall range, that's like the overall size of that box and whisker plot. Remember, the range of any set of data is the max minus the min. So really what they're asking here, the smaller range, well, the first one goes from, it looks like 65-ish all the way up to like 88. And the second one goes from 69 to just 80. So again, just by looking at it, you don't have to actually subtract those values. Just by looking at it, those whiskers in city B are way closer than the two whiskers in city A. City B, those two whiskers actually even fit into the quartiles from city A. So B has a smaller overall range there. And then which city has a larger median noon temperature? When they're specifically asking for the median, we're looking at that middle term. So a lot of what's going on here today is vocabulary and understanding what you're being asked as in terms of the language being used. So the median value, you've got city B is at 75, city A is at 73. Which city had a larger median temp? That's going to be city B. Okay, so just looking at the pictures, you can answer all 4 of these questions as long as you're understanding the language being used here. Okay, so I've got a 15-minute limit on these videos. I've got 2 more examples to get through with you guys, and I've got about 30 seconds left on the video. So I am going to stop this video now, and then there'll be another second short video to finish up these notes.